Okay, good evening, students. Today I am going to solve some of the problem which will be related to model number 4. Okay, which is related to model number 4. Problem 1. An alternator has 9 slots per pole. Okay, 9 slots per pole. The coil span is 8 slots. The coil span is 8 slots. Find the pitch factor for fundamental frequency. Fundamental frequency. Okay, so this is the problem which has been taken from model number 4. Now you please go through the problem. This is alternator, 9 slots per pole, and by using this 9 slots per pole you have to calculate the pitch factor for fundamental frequency. So pitch factor for fundamental frequency, you know the formula K P equal to cos alpha by 2. Okay, cos alpha by 2, but we don't know what is alpha. Alpha is nothing but which is the coordinating angle alpha. Okay, alpha equal to coordinating angle. This alpha formula, it is total (180° minus coil span Okay, so what is mean by a coil span? The formula for coil span is equal to 180° into coil span in terms of slots whole divided by number of slots per pole. Okay, now you substitute 180° into coil span in terms of slots. So how many coil span is available? The coil span is 8 slots. So 180° into 8 divided by number of slots per pole. So what is number of slots per pole? As per the problem, it is 9. Substitute. Please give me the answer. Anyone?
160, sir.
160 degree. Okay. So this value substitute here. So 180 degree minus 160 degree equal to, you get 20 degree. Okay, this is coordinate method, 20 degree coordinate method. So now substitute Kp equal to cos of 20 degree divided by 2. So what is an answer, ma? Final
0.98.
0.9848. Okay. This is one method. This is method 1. Method 1. In method number 2, we can calculate the angle displacement also. That is, we can calculate by using the number of slots, we can calculate the angular displacement beta. The another name of pitch factor for fundamental frequency, we can call it as beta also. Beta equal to 180 degree divided by n. So 180 degree divided by n value will be number of slots. 9, 8, 20. So this value will be electrical. Because we are talking about a generator, usually the generator will convert mechanical into electrical. Okay, so better don't mention this method 1 and method 2. Okay, that is somewhat confusing. Better you mention this method. In your examination, I can mention find the pitch factor for fundamental frequency, and there will be one more question, and angular displacement between the slots. Between the slots. Okay, this is the question. So the pitch factor for fundamental frequency will be Kp. Okay, this is pitch factor. Pitch factor. And this beta will be angular displacement between the slots. Okay, this is problem 1. I understand. So the pitch factor formula Kp equal to cos alpha by 2. So from that I can get Kp. And angular displacement between the slots will be beta equal to 180 divided by n, where n is in number of slots per pole, it is 9. Substitute directly, you get 20 degree electric. Or understand? Any doubts? Any doubts? Okay.
No, sir.
Okay. Then another second question. Next problem. Calculate the distribution factor for distribution factor for a 3-phase distributed single layer winding of the armature of an alternator. Okay. The alternator has 2 poles and a total of 18 slots. 2 poles, a total of 18 slots. This is problem 2. Okay. Now for this above problem, first step you have to write solution. Solution. And what they're asking, calculate the distribution factor. Okay. Write the formula. For any problem, first write the formula because in your examination step marks is available. Distribution factor KT equal to sine m beta by 2 divided by m into sine beta by 2. Beta by 2. Beta means angular displacement. M means number of slots per pole per phase. Okay, these values you do know. So, first step 1. So, first you have to calculate M. M nothing but number of slots per pole per phase. So, M equal to N divided by number of phases, which is equal to N, where N is nothing but number of slots. So the number of slots, how much? Number of slots, it is 18. Okay, N means number of slots per pole. Okay, N is nothing but, it is, note down, N is nothing but number of slots per pole. Okay, so how many slots are there? 18. 18 per pole, right? How many poles? 2. 2. The whole divided by number of phases. How many phases? 3. So what is the answer? Therefore M equal to how much more? M equal to, anyone?
3, sir.
3. M equal to 3. Okay. Then next one is beta. Can anyone tell me what is the formula for beta? Beta equal to 1
180 by n.
by n. Okay, so 180 degree divided by n. N means number of slots per pole. How much? 18 divided by 2. 18 divided by 2, you will get 9, right? So 180 degree divided by 9, it will be get 20 degree. Okay, so you got beta and you got m also, both you got it. Now substitute it. Therefore kd equal to sine of 3 into 20 divided by 2 whole divided by 3 into sine 20 degree divided by 2. So finally you will get 0.96. See, these are problems are direct substitution problems. Okay, maybe a small concept, okay, which will be indirect method. So therefore kd equal to 0.96. Any doubts? Any doubts? Students, you have any doubts?
No, sir.
Okay. Can I proceed for third problem? Third problem, can I proceed? Okay. A four-pole alternator has an armature with 25 slots and 8 conductors per slot and rotates at 1500 rpm, and flux per pole is 0.05 Weber. Calculate the EMF generated if winding factor is 0.96 and all conductors are in series. Conductors are in series. Okay. Now by using this data, you are going to calculate EMF formula. Okay. Solution. Solution. First, write the formula. EMF generated. This is alternator. So you know the EMF generated EMF formula. G equal to 4.44 K, Kp Kd into flux into frequency into T, number of turns. Okay. So now you don't know whether frequency is available. No, frequency is not available. So how to calculate frequency? We know that synchronous speed ns is equal to 120 fs by p. This is supply frequency fs. So from this, fs equal to ns into p by 120. So how much ns? Synchronous speed 1500 into pole, number of poles, 4 pole, it is 4 pole divided by 120. What is the answer? fs equal
50, sir.
50 hertz. This is 50 hertz. Okay. Next, now as per the question, there will be a frequency calculated, number of turns you don't know, but flux we don't. We know the flux, it is in the question. Flux per pole is 0.05 Weber. Okay, in the question itself the flux is given, flux equal to 0.05 Weber, it is given. Okay, now you don't know the turns, number of turns. So how to calculate number of turns? Turns formula, number of turns is equal to Zp divided by 2, where Zp will be the number of conductors connected in series. Number of conductors, Zp is nothing but number of conductors connected in series divided by 2. Okay, so how many number of conductors are there? Number of conductors, how many? It is number of conductors connected in series means Zp is equal to, we know that, take down Zp is equal to number of slots into number of conductors per slot. Okay, better instead of putting this arrow mark symbol, better I can put bracket. Okay, Zp is nothing but number of conductors connected in series. Okay, therefore Zp is equal to number of slots will be 25, number of conductors per slot is 8, we'll get 200. Therefore number of turns T equal to Zp divided by 2. So 200 divided by 2, how much? Which is 100. Okay, then next, therefore T equal to 100. Number of turns is
200 by 3, sir.
200 divided by, where it is 3?
3 number.
No. Here I have written, you see, T equal to Zp divided by 2. Zp by 2.
Sir, Zp means number of conductors per phase, sir.
No. Zp will be number of conductors per phase. No. Zp is the number of conductors connected in series. Please see the question. Here in your question itself they have given, maybe it will be a phase also, but here they have clearly mentioned all the conductors are in series. Okay, so in terms of, if they mention the series formula, because you know the structure of the winding, this is a structure. This is a structure. Okay, these two windings are connected in series. If the two windings are connected in series, what happened? The current will be same. The voltage drop across the each winding will be different, but it is connected in a circular structure. So in terms of circular structure, here whatever the resistance and the reactance term connected in R phase, the same resistance reactance only connected in the Y phase. So all the phases all similar. So in terms of conductors which is connected in series, okay, if they mention it, you have to take number of slots into number of conductors per slot. In your question they are not mentioned how many phases are there, because we are not talking about the phases. If we are mentioning the phases, calculate the EMF generated per phase, then you can substitute divided by 3. Okay, so is in your problem they are not mentioned number of conductors per phase. Okay, the problem is indirect substitution. So are you got it, Ashwanand? Are you got it? Have you got my point? Hello. Okay, then substitute all the parameters. And one more thing, as per your question, if the winding factor is 0.96, what is mean by a winding factor? Winding factor is nothing but it is the product of concentration factor and distribution factor. The notation is Kw. Kw is equal to Kc into Kd. Okay, this value is already given directly, 0.96. So therefore EMF generated is equal to 4.44 Kc Kd into flux into frequency into turns. Now 4.44, the combination of this Kc and Kd, I am putting Kw. double F 5s T. Now substitute all the parameter. 4.44 into kW, how much? kW 0.96 into frequency 50 into flux 0.05, number of turns 100. Can anyone give me the answer? How much now?
1065.6.
Therefore E equal to 1065.6 volt. This is the EMF generated of your alternator. Okay, EMF generated of alternator.